today's lesson, we are going to be looking at domain and range of functions. So this is just going to be a continuation of what we've looked at already. Just going to add some extra information to it, or look at domain and range under certain scenarios. So if we kind of recall from our last lesson, we talked about the Humber River pedestrian bridge in Toronto, and looking at the equation that models it. Right, h at x is equal to negative 1 over 144 x squared plus 5 over 6x, where h is the height in meters above the water and x is the distance that you have walked. So if we look at that model, we look at it graphically, what is the domain and range of this function in this scenario? Now looking at it, you might say, okay, well, domain and range, or great, domain is your x value, so x is any real number, given that it is between 0, because we don't see an arrow here, 0 and, well, we have an arrow here, so that means it should go on forever, so infinity. And then our range, right, we see again, y is any real number, given that, and then we have our highest, it looks like it's about 25, and then our lowest, we have an arrow on the one end, so we'll maybe say assume negative infinity, and then we have 25. Now, looking at this, right, if we think about this model, right, the key thing in this question is that it's domain and range for this scenario, right? And looking at this, are there any restrictions on what our domain and range can be, or is what we have down correct? And because we're talking about this scenario, there are some restrictions that come into play, right? And one of them focuses on the domain, right, left and right. So we can't actually go anywhere beyond here and here. And why is that? Why can't we go beyond 0 and 120? Well, the reason we can't go beyond that is because if my line continues right down here in this direction, what is that symbolizing in this scenario? And remember, this is supposed to represent a bridge, right? So anything beyond 120, when our line goes below 0, we're underwater. Same thing on the other side. If I go anywhere beyond 0, we're also underwater, because our graph would be going down, and that's the model for this bridge. So our bridge can only exist in certain areas, right? It's going to exist only above water, right? So our range and our domain, or our domain and range, have to change a little bit, right? Because the lowest our bridge can be is 0, not negative infinity, because our bridge isn't going into the water. The highest is fine. The highest up here at 25 is fine, but we need to just make sure we make the changes so that our lowest range is 0 and that our highest for the domain is 120. And again, the reason being, if I go below 0, I'm underwater for the range. If I go beyond 120, I'm underwater as well for my function, which is we can't have, right? Our bridge isn't going underwater. So depending on the scenario that we deal with, right, there may be some restrictions for the domain and range. So we do have to be careful. We can't just assume that these values or make the assumption that graphically whatever we see in terms of the arrows, things like that, is true for our scenario. That may not be the case depending on what our scenario is. So for example, the one we just looked at with the Humber bridge, right? X values, X values below 0 and above 120 do not make sense. And then, again, the reason being, right, X represents the distance you have walked, right? So X is equal to, or you can say X is the distance walked on the bridge. So you can't walk negative values. So we can't walk negative values, and we can't walk longer than the bridge. Right? So there are some restrictions here. Values can't be below 0 or above 120. Right? They can't be below 0 because we can't walk a negative value on the bridge. And it can't be more than 120 because we can't walk longer than that on the bridge, because the bridge no longer exists after 120 meters. Right? So we do have some limits on what the values have to be based on the scenario that we're dealing with. For the range, it's the same idea. So Y values above, above 25 and below 0 do not make sense. And again, the reason being for this, remember, Y represents the height. So the reason we have these kind of restrictions, right? We can't go underwater. So we can't go underwater. And also, the bridge has a maximum height. It doesn't continue on forever. It does have a maximum height. So the bridge has a max height. So again, we do have some restrictions based on the scenario for our range, our domain and range. So we do have to be mindful that even though our graph might continue on forever, we have to be mindful of the scenario and think about what restrictions or what values can exist. Right, so for example, each arch in the BCE Place Galleria can be approximated by the function h at x is equal to negative 0.55x squared plus 26, where h at x is the height in meters above the floor and x is the width in meters from the center of the hallway. So we want to think about what is the domain and range for this function in this scenario. So here we have a kind of cross section of this arch. So we need to think about our domain and range. We see some values. So let's start with our domain. Domain x is any real number given that, and we need to think about the lowest and the highest value. Well, our lowest values are going to be here. Our highest value is going to be here. Now, there are no arrows in this function. So this function was drawn to model the specific scenario. We don't see arrows at the end, so it's specifically going to be these two exact values. And if we, I'm just going to say these values are going to be negative 6.9, or we'll say negative 7, negative 7 and 0, and 7 and 0. So that is going to tell me or give me information for my domain. So x is going to be greater than or equal to negative 7, but less than or equal to positive 7. Right? Typically, we might think, okay, well, maybe there's arrows, or maybe we're going to assume they're arrows because I know this looks like a parabola or a quadratic, and I can tell that by the equation as well, that it's just going to continue downwards and out and spreading out left and right forever. However, because it can't go anywhere below that because technically anything beyond this, going underneath, would be considered underground. And our archways are basically from the floor level up. Our range, similar idea, y is any real number, given that if we think about the max and min, right, or the highest possible value and the lowest possible value, the highest possible value, that's easy to see. We can see that in the equation. We can see that from the graph, right? This is our max height. So right off the bat, we can clearly see that we're not going to have anything higher than that value. So we know our highest value is going to be 26. Now we have to think about what is the lowest value. And again, we can think about, okay, at lowest value, what's the lowest possible height my arches could have? And just based off of that, our lowest possible value would have to be 0 because we can't have a negative height. We don't really have thing as a negative height in meters. Now, we could be a negative height if we're going down, right, below sea level, something like that. But in terms of the arches, when we're talking about the height of an arch in meters, we're not going to see a arch that has a height of -3 meters or something like that. So, and again, because that would be it's going underground or it's inverted. So our range, y is any real number, given that y is greater than or equal to 0, but less than or equal to 26. So again, it's just making sure that we understand that based off of this scenario, we might have to change our domain and range to make sure it represents it correctly. Next example. So a cannon is fired from the top of a cliff that is 44.1 meters above the ground. The height h of t in meters of the cannonball. Oops, I spelled cannon wrong. Wrong cannon. The cannonball above the ground after t seconds can be found using the given function. H of t equals -4.9 t squared plus 22.05 t plus 44.1. We want to state what is the domain and the range of this function. Right, so I have my table of values. I've graphed my function. Right, I want to figure out, okay, what is my domain and range? Let's start with domain. For a domain, x is any real number, given that. And then what are the possible values for x? Well, if I look at my quadratic here, right, I look at this, I come in from the left and the right, I see the lowest value is down here. I have arrows and the highest value is up here. Now, if I think about this, maybe not just right there, but kind of here, or nope, sorry, we do see this. If I think about this, right, a cannonball being shot, right? What values make sense horizontally? Right? If we're looking at time and meters, right? X is going to be the time, y is going to be the meters. What values make sense for time? Because looking at this, if I'm just looking at this function, I would probably say -1.5 greater than or equal to x, which is less than or equal to 6. But there is an issue with this format. Oops, 3. There is an issue with this format. And the issue is, can we have a negative time? We can't. Right? So this scenario, time usually always starts at 0. The reason for that is this is the portion, right? If we imagine kind of a cross section or a two-dimensional view, right? This is the cliff here, right? So this portion here does not make any sense. This portion, but everything less than 0 for an x value does not make sense, right? We can't have time be in the negatives. And if I'm looking at that, that means the ball or the cannon is going to be shooting backwards down into the cliffside, which is not how a cannon works, right? It shoots out and goes in one direction. It's not going to come back and go into the hill. So everything before 0 does not make sense for this function. So that means in actuality, my domain, the lowest possible value is going to be 0. The highest possible value is still going to be 6. The range. So the range y is any real number given that, and what are the possible values for y? Well, hopefully we can easily see the highest value, right? And I can even go to our table here and take a look at it. I can see the highest value, right? That maximum is here, the maximum height. So I know that's going to be my highest possible value, the 68.2.6. Somewhere up here, 68.6. Based off of our values, that's going to be the highest value, or the maximum for our range. Now we have to think about what's the lowest. Right? Well, we do have arrows on the end, but we have to remember what makes sense for this scenario. Can we have a negative height, right, for our cannonball? No, not really. You could argue, well, maybe the cannonball flies into the ground. Then, okay, yes, you could maybe argue that. But we're assuming that it's staying relatively on the surface of the Earth. It's not going anything below it. We're not going to get negative meters. So that means the lowest possible height that our cannonball could have, right, or whatever we fire out of the cannon, would have to be 0, or ground level. Right? So ground level is the lowest possible y value. The highest possible value, y value, is the maximum height, or the arch, or the vertex, you might say, of our pathway, which is the 68.6. So again, just making sure that we are taking into consideration the scenario when looking at domain and range. So our last example, the path of a rocket fired at a Canada Day fireworks display is given by the formula h at t is equal to negative 4.9 t squared plus 24.51 t plus 0.245, where h at t is the height in meters of the rocket above the ground, and t is the time in seconds. So we want to graph a suitable, or graph the function for suitable values of t, find the maximum height of the rocket, and then at what time does the rocket reach the maximum height, for how many seconds was the rocket in the air, and state the domain and range. So if we look at our graph here, we have our scale here. Essentially all we're going to do is just create a table, x and y. We're going to use that equation, h at t is equal to negative 4.9 t squared plus 24 plus 24.451 t plus 0.245. So essentially what we're going to be doing is we're going to come up with reasonable or suitable values for t, or time, or the x. We might as well just change our variables here, t, h at t. Right, so I'm going to do 0, 1, 2, 3, 4, 5. Right, I'm just choosing realistic values for t. 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds after launch. And essentially what we're going to be doing is basically solving this equation, or this function, for when t is 0, when t is 1, when t is 2, right? So very essentially using the function notation that we did before, finding the value, or finding the height at a given time based off of this equation. So I plug 0 in, I get 0.245. If I plug 1 in, I get 19.796. 2 is 29.547. 3 is 29.498. 4 is 19.649, and 5 is 0. So if I want to plot that, 5 and 0, 1 and 0.245, 1 and 20 just below, 2 and 29, 3 and 29 essentially, 4 and 19.67, roughly what we just saw. And if I sketch my quadratic, it looks something like this. So now I've graphed my quadratic, right, or the pathway of the firework. So now we have to figure out, so we did A, right, we graphed it. B, what is the maximum height? Right, then what is the maximum height of our rocket? And I can look at my table of values and see, okay, I have 2, which is 29.547. I have 3, which is 29.498, right? So those two values are roughly the same. So it's going to have to reach its peak somewhere between those 2 points. Right? And if I look at my graph that I roughly sketched, the maximum height is going to be approximately we'll say 31 meters. B, or sorry, not B, we just did B. C is asking, okay, what is, or how long does it take to get there? So again, making the assumption that we are going to be between these two values, right? The approximate overall flight took, or where the maximum was about, say if it's in the middle, was approximately 2.5 seconds. So 2.5 seconds into its flight, it reached its maximum height. D is asking for how many seconds was the rocket in the air. Well, we can see where it hits ground, right, which is over here. So we can see that this x-axis is the ground. So then that means it got launched at 0, landed at 5. So the total flight time was 5 seconds. And then now the next thing we want to do is just state the domain and range. So domain will probably be relatively straightforward. For our domain, right, going back to looking at the different times that we used, right? So first, x is any real number, given that, and then the lowest is 0, and the highest is 5. So those are all the possible values for x. For our range, again, same thing, y is any real number, given that or such that, and then we look at the heights. What are the possible values for height? Well, we have 0 as our lowest when it comes back down and hits the ground. And then our highest is the highest peak or the vertex of this pathway, which would be by looking at this 31. And that's the domain and range. Right? It is a little bit different because we're not making the assumption that the line continues on forever, because that would not make sense for the path of a rocket. We're not launching it in negative time, and we're definitely not launching it underground and having it shoot its way up through the ground. And on the end portion of the pathway, it's not traveling into the ground, right? It's not burying itself into the ground and continuing on. So just different things we want to take into consideration when we are looking at domain and range for functions or specific scenarios. Right? There may be some restrictions based on what the scenario is, right? Whether it is you not being allowed to have a negative time, not being allowed to have negative heights, things like that. So we just have to be mindful if we're ever asked about domain and range. Is there a scenario attached to this function? or relation, and does that restrict what the domain and range could potentially be?